Oh, wait, you're listening?
Okay.
All right.
Okay.
All right.
You're
Listening
to Radiolab.
Radiolab.
From
WNYC.
See?
Yeah.
What's another word for a male frog that has some children?
What? What's another word for a male frog that has children?
Daddywog. Dadpole.
There you go!
Yeah.
Okay, sorry.
I feel cash. I already feel like we're at a sleepover instead of like at an official recording.
Hey, I'm Lulu.
I'm Latif.
This is Radiolab.
And this week, we brought in a third host, as if there weren't enough of us. A host we are quite a big fan of. Alie, your show is awesome.
It's so great.
Thank you.
Her name is Alie Ward. I actually realized during our conversation with her that she is my neighbor. But we brought her in because we wanted her to tell you about her podcast.
So let the games begin. Ask me anything.
What is the name of your show and how would you describe it?
So Ologies is a comedy-ish science podcast where we explore a different ology every episode. So it might be geology one week and then filamentology the next, which is the study of kissing. So
Alie has taken on so many ologies.
Testudinology, which comes from the Latin testudo for tortoise.
Enigmatology, Hagfishology,
Would it be Raccoonology or would it be
no.
Meteorology, Apiariology,
Chickenology,
Melaninology,
quantum ontology,
Chronobiology,
carnivorous phytobiology, flesh-eating plants.
Your urology episode was one of my favorites. And I did not think I would, I very reluctantly clicked on that.
Thank you.
And we brought Alie on because her show is kind of like a kindred spirit to our show, but also it's very different at the same time. Like for our show, we talk to a bunch of scientists, but it's usually in the context of a story or a big idea we're interested in, and then we try to make it all add up to something. Alie does not do that part. She just will be like, oh, this scientist is interesting. And then they will sit down and they will just go to town. And actually, one of the things I love about your show is like your What Matters is totally different than our What Matters. Like, what does it matter when it's a random thing that it seems like maybe only this one scientist you're talking to cares about?
I love this question and I completely get it. So here's the thing. Science is everywhere. Science is in how you steam broccoli. Science is in how you park your car. Science is in who you fall in love with. Science is why you sweat when you get a text message that freaks you out. Like, it's not just about diagrams and textbooks. And I think it's also interesting that a lot of people who are not scientists think that scientists are jerks and pedantic and are there with like a huge book of facts to tell them that they're wrong about things. And I wanted to show that like scientists are curious little weirdos who found their niche in whatever made them passionate, and they make mistakes and they have hypotheses that end up being wrong, and they're figuring it out too. And so humanizing scientists, I feel like, galvanizes people to care a little bit more every time they see a research paper. They think, I wonder why this person studied this, or I wonder how long it took to get this published. And so the civic duties that we have to protect things and care about things become easier for people when they have a little bit more context.
But like, okay, so like how do you know that people will stay with you for all of these, to go down, like how far they'll follow you before they'll just be like, Alie just totally lost it. Like, this is
Lost the plot.
Lost the plot.
Yeah, I mean, it's really kind of more of like a lightning bug kind of darting around and just following the light.
So for the rest of this episode of our show, we're going to follow Alie into an episode of her show as she follows the light, bouncing around like a little lightning bug like she does, into the dark.
Oh, Scotohylology. Scoto means dark, hylology means matter.
We're going to play her episode on dark matter for you.
That was a rare one where I worked with the ologist to be like, there needs to be a word for this. How do you feel about this? And he loved it.
You coined a term?
We coined it.
It's one of the very few conversations I've heard that actually make dark matter make sense to me.
And even feel like it matters.
Yeah. So we're going to turn it over now to Alie with UC Riverside theoretical particle physicist and dark matter expert Flip Tornado.
And just a quick heads up, the lovely Alie Ward is not afraid to dirty
words.
her tongue. That's not an expression. She's not afraid to swear. So there are a few swear words ahead. Here we go.
Did you set out to become a theoretical physicist? How does one land in what I feel like is the hardest field possible?
All right, here is my origin story. I wanted to be an author.
Really?
I had no idea why, but I was very passionate about writing, the idea that one could have a voice.
Mm-hmm.
And so growing up, I was a huge fan of LeVar Burton's because of Reading Rainbow.
Oh, love. Yes.
Reading Rainbow, amazing.
But you don't have to take my word for it.
So I would watch Reading Rainbow, and at some point in the back of my mind, I realized this person who does Reading Rainbow is also on this TV show, Star Trek.
Mm-hmm.
And in high school, I'd started watching Star Trek a little bit. It was still on at the time. I picked up the book, The Physics of Star Trek by Lawrence Krauss. And this was a really fun ride because it was the first time I'd thought about a scientific subject as something where there are open questions, and these open questions are fun and creative and exciting. And any time that I lost track of it being exciting, I just watch LeVar Burton as Geordie LaForge as a chief engineer on the
know
Enterprise.
it well. Oh my gosh. My sister and I used to watch The Next Generation as well.
It was the best.
Yeah.
We can't change the gravitational constant of the universe, but if we wrap a low-level warp field around that moon, we could reduce its gravitational constant. Make it lighter so we can push it.
So I think that's what got me into this idea that, hey, these black holes in the show, these are real.
Mm-hmm.
We should understand these things. There are fundamental questions that are not only abstract and things that you'd find in textbooks, but they're fun ideas. And it was the creative spark that was really exciting, that someone could write a science fiction piece about these actual things. And that's what got me going with physics.
Do you write still at all?
I was never a great writer, and you can ask my collaborators that my paper writing is slow and tortuous. But I would like to eventually write something as a popular book.
Oh, yeah. I feel like that is in your future. But when it comes to matter and dark matter, I mean, slow it way down for baby brains like mine.
All right.
But from what I understand, and the first time I ever read this was like, okay, all of the matter that we can see and touch and feel and everything makes up about 15%.
Yeah, depending on how you're counting. But yeah, it's a tiny fraction.
Like a third of that. So everything that you can see and feel and touch and smell, that's 5% of the universe's mass and energy. There's another 95% of pure mystery.
So then what the fuck is everything else? What is it?
That is this is the mind-blowing thing. We've known about dark matter indirectly for 100 years.
Mm-hmm.
And I think it hasn't been until fairly recently that this has come to the forefront of, we really ought to figure out what this stuff is. Because, as you said, we spend all of our lives learning science, art, history. Everything you learn from a textbook is basically about that really tiny slice of visible normal matter and the history of that normal matter in this universe and in this world and in our culture. But it turns out for every, what's the fraction? I think if you look at the amount of energy, so energy is a good measure for stuff, 25% of the universe is made of dark matter. Ooh. And only 5% is made of the stuff that we're used to.
Wow.
And so there's 5 times more dark matter than ordinary stuff. And in fact, it's so much more that we look at our galaxy and we think our galaxy is huge. Our galaxy is almost everything we could possibly care about. Our galaxy is only here because it is swimming in an ocean of dark matter that provides the gravitational pull to keep the galaxy there. Like the galaxy formed because there was dark matter. What? So where we are right now with Scronobiology, is that what we're doing?
Yes, nailed it.
This is the fish scientist discovering for the first time that there's this thing, water, that we're swimming through. We should figure out what this water is.
Wow. And now the other, let's say, is the other 70% dark energy?
Good, yeah. So that is a great, I was both hoping and not hoping that you would bring that up. Right, so 25% dark matter, 5% ordinary matter. That doesn't add up to 100%.
Mm-hmm.
And so the rest is indeed dark energy. And I'm excited that I have no idea what dark matter is and that there are great things to do in that field. I have no idea what it is. Dark energy, I have no fucking idea, and I'm terrified. And there's a reason why I don't work on it. It's one of those shows, right?
Yeah, of course. Very much so. Especially this topic. There's going to be a lot of boggling. Trust me. So what? I mean, okay. So about 100 years ago, was that when we realized, I say we, the royal we here, like that something is not adding up?
That's right. Yeah. That's right.
When did we realize that?
I think this was about 100 years ago. The first astronomical observations were, and this is what's really, really trippy, the origins of Scotohylology were really in astronomy. And people would look at galaxies and look at how fast stars were moving in those galaxies. And just using ordinary, non-fancy Newtonian physics, the type of physics that students groan over in high school, they figured out that these stars moving around these galaxies were going a little bit too fast. It's as if there was more gravity than they had accounted for just by counting stars. And I'm going to do a great disservice to my astronomer colleagues, but for the most part, the astronomy field said, that's curious. For I don't know, maybe 50 years, 60 years. Because there are lots of curiosities in astronomy.
Right.
Over the next 100 years, we had more and more mounting evidence that this additional gravity, which in the 1920s, who cares if we just didn't happen to count all the stars correctly? But now there's more and more evidence coming from more and more sophisticated measurements that not only is there more stuff, but that stuff cannot be the stuff that we're made of.
So there is stuff all around us, out massing us and out energying us, maybe by a factor of 20, but we can't see it and we don't understand it. So this whole time, we thought that we were a cookies and cream milkshake. We're just the Oreo bits, and we're surrounded by an invisible milkshake that can seep through us. We don't know what it is or what it does. So dark matter, it doesn't interact with light or electromagnetic forces, which is why we can't see or feel it. So why do we know it's there? Fritz Zwicky first coined the term dark matter in 1933, more on him later, but it wasn't until this astronomer named Vera Rubin crunched some numbers and hypothesized that dark matter exerts gravity. And without that gravity, galaxies would just fly apart and scatter if it all just depended on the normal matter or baryonic matter, which is the atomic stuff that we know of, like protons and neutrons and electrons. So when did she figure that out? Oh, just in 1978. We just found this out a split second ago in the universal timeline. Get this. So Dr. Vera Rubin, she did her calculations at this observatory that didn't even have women's restrooms. There were no ladies' rooms at the observatory. She had to cut up a silhouette of a dress and paste it on one of the men's rooms. And then, when she was done crafting, then she pioneered some giant theories about the existence of the universe. And she died in 2016. She was never awarded the Nobel Prize, and they unfortunately do not hand those out posthumously, which is a bummer. But you can name your dog Vera or your cat Rubin and remember Vera Rubin that way. But anyway, dark matter, it's something else.
It cannot be the stuff that we're used to from chemistry. And then the fundamental particle physicists, the elementary particle physicists realized we've been spending the past 5 decades trying to categorize the elementary particles of nature. We're trying to have the most fundamental periodic table. And you're telling me that there is something that we're missing and that we definitely have to put on here?
Wow.
And this became a big thing, if you'll permit me an aside.
Yes.
I was hoping you'd say that.
So I'm going to get the history a little bit jumbled, but this is the moral history. This is the way that we're going to remember it.
Okay.
In the 80s and 90s, there was one big hot question in particle physics. And that question had to do with the Higgs boson. So the Higgs boson that in 2013 won the Nobel Prize for its discovery. Big deal. Big fucking deal in particle physics.
And now that's sometimes wrongly called the God particle.
Yes.
Okay.
Yeah.
Right.
That is the quote-unquote God particle.
Right.
And if you ask physicists in my generation, its discovery was more like the Satan particle, where we had to really do some soul searching, because in the 80s and 90s we had realized there's probably a Higgs. If there's not a Higgs, things get way more interesting. But if there's a Higgs, something isn't quite right in the theory, because for all the reasons that we needed to have the Higgs, if the Higgs had the mass and the properties that we needed it to have, somehow it just didn't seem right. It was far lighter in mass than it really ought to have been. So we now know it weighs about 125 times the mass of a proton.
Wow.
Which is pretty honking for a fundamental particle. And our prediction, naively, if I gave that calculation to a first-year grad student, they'd say it's probably way heavier than that. It's like balancing a pencil on its tip. The quantum corrections to its mass would make the Higgs heavier than it actually is.
And just some very brief background on this. So Higgs particles make up the Higgs field, which is this big cloud of bosons or particles. So matter started out zipping around like photons, just unencumbered by mass. But interaction with the Higgs field is what makes matter interact with gravity and have that mass be gravitationally attracted to each other. But Higgs bosons, very hard to find. You have to get like a large Hadron Collider, say, maybe 27 kilometers under Geneva. And then you got to race protons at each other. You got to explode them. And then you got to measure what's left, aka a decay signature. And if you're looking through all those pieces and you have pieces and parts for what could have been a Higgs boson that existed for a fraction of a millisecond, then that's almost proof. But for a long time, this possibility of the Higgs particle had vexed science for years. One leading scientist wanted to call it the goddamn particle, but his book publisher was like, let's go softer, and naively made the facepalm modification to just call it the God particle, which has been making physicists cringe for decades now. But yes, essentially, things just didn't add up.
And so this was a huge puzzle. It's analogous to having an ice cube sitting in an oven, and you turn the oven on, and the ice cube's still there.
Wow.
So we called this the hierarchy problem. And for people like me, we write it with a capital H when we write our academic papers. It was a big deal. It seemed to be the reason why our theory of particle physics just could not be complete.
So prior to 2013, they knew something wasn't quite right.
And so we had these great exotic theories. They had funny names: supersymmetry, extra dimensions, compositeness. Maybe the electron and its cousins are not fundamental, but are actually made of smaller things.
Oh, wow.
So this was the heyday in the 90s of doing particle physics. And right around that time, as we were developing these really awesome theories, people realized, hey, in order for this theory to work, meaning in order for protons not to decay too quickly, in order for the universe to actually look like the way it does, we need to tweak it a little bit. And one output is we get these new particles that stick around. They don't decay. They're just around. That's kind of weird. And I imagine there's some particle physicist, sitting in his office saying this, and an astronomer walks by and says, "You have particles just sitting around, contributing mass? Have you heard about this anomaly that we have? There's more mass in these galaxies." And so particle physicists we're kind of smug. Just said, "Oh, yeah, okay, good. I have discovered what your dark matter ought to be. In 15 years, when we turn on this collider, we're going to discover what this particle is. We'll measure how heavy it is, and I will tell you exactly what's in these galaxies that you've been looking at for the past 100 years." This was the promise.
Yeah.
And so particle physicists didn't even care about the dark matter, because that was the output of this elegant theory that solved the capital H hierarchy problem.
And just a side note, so the capital S standard capital M model of particle physics involves this uniform framework for understanding electromagnetic and weak and strong interactions. And the hierarchy problem is the difference between the way a weak force, which is a force that allows protons to become neutrons and then back and forth, vice versa. So that weak force is actually not weak at all. It's 10 to the 24th times stronger than gravity, but only at really short distances. So this was the big, strong, weak elephant in the physics room.
So that's how I was trained as a grad student.
Yeah.
And the year that I graduated was 2013. I had written some papers on extra dimensions and all of these exotic new things that we would predict that we would see at the LHC. And by the time that I turned in my thesis, it was pretty clear that none of those things would be discovered.
Wow.
We had discovered the most basic, most boring version of the Higgs boson, and none of the things that we predicted for the overarching theory that would explain why it was there. And then we got stuck.
Oh.
Bummer. What a mind bender, huh?
And I think this is where there's been a bit of a renaissance in the theory of dark matter.
Mm-hmm.
Because on the one hand, the smug particle theorists like me, who had assumed that of course, dark matter is this thing. All of our best theories predict this thing. Well, that's out the window. But dark matter is still out there. And meanwhile, actually, all of these theories that we spent our time building and cutting our teeth understanding, maybe the simplest versions of those guys are out the window too. So what are we working on? So several of us are still working on understanding the Higgs, but armed with all of these new fancy techniques for building theories, several of us went on to think about dark matter, because now we can look at this problem with fresh eyes without the prejudice of, well, there's this more important problem that has this more important solution, and this is just the byproduct of that thing. Now we've been thinking more open-endedly about what dark matter could be, not just what we expect it to be.
More on dark matter from Flip to NATO after a quick break. Lulu.
Latif.
Radiolab. We are back with Alie Ward on Scrotohylology,
AKA the study of dark matter,
with theoretical particle physicist Flip to NATO. Here's Alie.
What about the name dark matter and dark energy? Because it's invisible at best, right?
Absolutely.
Who decided that it would be called dark? Who decided that it would have a spooky name?
That is a great question. I think it was Zwicky, who was a famously cantankerous physicist in the early part of the 20th century.
So yes, this was 1933 with Caltech's Fritz Zwicky. And when you hear the words famously cantankerous, I know you want the story time. And among a lot of different legends and slander and feuds and jealousy and what sounds like a little, maybe a touch of old-timey verbal abuse, if his enemy stories were to be believed, Zwicky would allegedly call his colleagues scatterbrains and spherical bastards. Spherical because, quote, they are bastards every way I look at them. Ooh, messy. I love it. But a 2008 article in Discover magazine features testimony from Zwicky's daughter, Barbarina, that Dr. Fritz was just so brilliant that he had a lot of haters. But he was the one
who coined the term dark matter. And what he meant was that it doesn't interact with light. Yeah, so usually we think things that are dark don't interact with light, but actually probably there's some junior high student out there who'll say, no, things that are dark absorb light. They're actually maximally interacting with light. If you're an astronomer, dark means you don't see any photons from it. Mm-hmm. So I think that's why they use the word dark. And to the best of my knowledge, I think dark energy, which was discovered a little bit later as a big question mark, they latched on to the branding that we developed. And they used the word dark to mean, just like dark matter, we don't know what this is. But at least dark matter, we had the idea that this was stuff. These were particles. Mm-hmm. I'm 99.9% sure dark matter is at least one particle. Mm-hmm. Dark energy definitely behaves differently, and it's a much weirder thing.
Do you drive around in traffic and think about this stuff? Like, can you ever escape theorizing about this?
Oh, that is a great question. I think the imposter syndrome in me says, I escape it way too much. No. But traffic in LA, as you know, is not a great place to have happy thoughts. But I often find myself thinking about physics in a swimming pool.
Really?
And so, for example, there's this idea of we are fish in an ocean of dark matter. That was something that I was thinking about while swimming. And I guess being in a mathematical discipline, you're sharpening your equipment, like having the finest equipment is really having a clear mind. Mm-hmm. And I can sit at my desk and I can do a calculation, I can write a paper, but the creative spark is something that usually happens outside of those environments. So walking around or having tea on my patio, that's where the magic happens.
And be honest with me, without having to name names, how many astrophysicists out there think that dark matter might be ghosts? What if dark matter is ghosts? What if dark energy is ghosts? What if it's all ghosts? What if we're swimming in ghosts?
There is a famous quote from Nima Arkani Hamed before the LHC turned on. And the quote was something along the lines of, we might turn it on and dragons might pop out. We have no idea what's going to happen.
So in a March 2008 New York Times article, this particle theorist who was at the Institute for Advanced Study in Princeton told the paper that there was some probability of almost anything happening, even a minuscule chance that, quote, the Large Hadron Collider might make dragons that might eat us up. Maybe he was just ahead of the curve in predicting the 2011 premiere of Game of Thrones. But either way, people were rightly pumped.
And that kind of encapsulated a lot of the excitement. There is something to be said about maybe dark matter is something much more exciting than particles. And there are theories where the dark matter, plural, could form dark atoms. Just like you have protons and electrons, maybe you have something like a dark proton and a dark electron that we can't see, but they can see each other. And those form dark atoms. And then it's not hard to imagine, well, those dark atoms could have dark chemistry. That dark chemistry can form dark life. That dark life could maybe there's an entire sentient civilization living in our dark matter halo where our galaxy is sitting, and we just don't realize it. But because there is 5 times more of them than there is us, we are the ghosts. We are the weird thing.
Wow. Oh my gosh. You're trying to make sense of dark matter using a field of math that applies to everything else.
Yeah.
Is there a possibility that there's a dark math? That there's just a completely different way of trying to quantify everything?
Boy. Okay. That is one perhaps for the philosophy department. And I say that very carefully because I think usually when a physicist says that's for the philosophy department, that's probably condescending. That's probably dismissive. That's how we say, I don't want to think about that. The assumption is math is logical rigor. And so that just has to be true. And I don't even know how to think about a different reality, a different universe that has different laws of math. I can imagine a different universe where the fundamental constants are a little bit different. Maybe there are more particles, fewer particles, but I don't know how to think about one where math is different.
Is there a myth that you would love to bust about dark matter? Like, what is one thing that the public thinks they know about it that they don't, other than that it's ghosts?
Oh, that's great. That is a great question. I'll start with a basic one. It's not antimatter.
Okay.
It's not antimatter. It's probably also not black holes.
Okay.
So these are the other two like exotic things that you learn from Star Trek.
Yeah.
So it's not antimatter because if we're swimming in the sea of dark matter, and if the dark matter were antimatter, it would keep annihilating with ordinary matter and producing light. So the fact that I was going to say that we're not a glow stick in the universe, but really that the fact that our galaxy isn't just being burnt up by the antimatter means dark matter is not antimatter.
Nice.
Until fairly recently, we would say it's not black holes because black holes are a totally different thing. But there have been some thoughts recently that there might be little tiny black holes that were formed in the early universe that would behave like dark matter.
How tiny are we talking?
That's a good... There's a range of sizes, but the story of little black holes is funny. For a long time, people were worried that turning on the LHC would produce lots of little black holes that would eat the Earth.
Sounds like fun.
But we were pretty sure that little black holes evaporate and would be relatively harmless. Little black holes are like little particles.
And do you think that those could be just on Earth in just little, pockets here and there?
Chances are no. I would bet no, but it is a theoretical possibility. It's attached to a whole bunch of other weird things. I think to make it work out gravitationally, you need to have extra dimensions and maybe a few extra dimensions. But it was a fun thing to think about 10 years ago.
Do you think that dark matter could be extra dimensions?
That is a great question. That is what I spent my summer vacation thinking about. So extra dimensions are a really funny quirk in the history of theoretical physics. I think the modern way of thinking about this is the people who work on extra dimensions don't necessarily literally believe in if I could just step in the right way, I'm going to be in some parallel universe. But in the mathematics, one realizes that if I can write a theory in 3 dimensions of space plus 1 dimension of time, I could write a theory in 4 dimensions of space plus 1 dimension of time, or in 5 dimensions of space and 1 dimension of time. No problem, right? It's another number that you add onto your mathematical expressions. And so it was easy to play with. And in the 1990s, one of the huge revolutions in theoretical physics was this observation that particular types of theories with extra dimensions end up giving mathematically equivalent predictions, when you ask the right question, to a type of quantum theory that is really hard to calculate. This is something called a duality in physics, and it meant that I could calculate something in my wonky theory of extra dimensions, and that calculation would actually mean something in an ordinary theory, ordinary meaning 3 dimensions of space, 1 dimension of time, that is highly quantum mechanical, but a perfectly plausible theory. And it was a type of theory that we really didn't know how to deal with until we had tools like this.
Mm-hmm. Tools like the Large Hadron Collider.
And so one of the fun things to play with is we have this really powerful machine to make predictions where we couldn't make predictions 20 years ago. Maybe we can describe cool theories of dark matter that, one, could explain why we haven't discovered dark matter, and 2, could motivate interesting different searches. Because this is where we are right now. Like, we need to figure out what is the best way to test these different theories of dark matter.
It better happen in my lifetime. I mean, I'm sure you think the same thing, given that this is your life's work.
Yes, yeah. And in fact, this is, for me, this is a difference between dark matter and dark energy. Both of them are things we have no idea what they are. I certainly have no idea what they are. Dark matter, we have an experimental program, and we know enough about it that I have faith that we have a sporting chance that we will learn something deep about dark matter in my lifetime. Dark energy, I'm not sure if we'll learn anything about it in the history of humanity.
Hey, Lot to Fear again. We're going to jump ahead because Alie asked Flip so many great questions.
What does dark matter look like in your head? Time travel. Yes, no, maybe? What is the best music to listen to while researching dark matter?
I would honestly just listen to a podcast that was only Alie asking questions. They are so great.
How much dark matter is in the room right now?
We actually know this.
Oh, okay.
In your coffee mug, you have about 1 gram of dark matter.
If you want to hear all of Flip's answers, you can listen to the full episode. We'll link to it on the website. But before we go, we will leave you with one last question and answer from Alie and Flip.
What about your favorite thing about what you do?
Oh, gosh. I love that on any given day, there are new things to learn. And either it's some experimental result that I want to understand, or some related field where I never had the chance to take that class as a student, but I see that there's an opportunity where dark matter might be able to do something, and then I can dig in and say, I have an excuse to spend my time reading this textbook or reading this recent article or talking to my colleague from a different department. That's the fun part.
That's great. I mean, I love that for the rest of my life, I'm going to be walking around thinking about a gram of dark matter in my coffee cup and sparkly webs and maybe ghosts.
Maybe ghosts.
You don't have to commit to that on the record. I just, for my own fun.
I would add to my yes and would be thinking about all of the dark matter scientists who are thinking about us and we are the maybe ghosts.
Oh, I love that. Thank you so much for doing this. This was a joy.
Thank you, Alie.
Oh my gosh. Yay.
Thanks to Alie Ward and her team for letting us share her show with all of you. Hopefully you'll go check it out. You can find it wherever you get podcasts or at ologies.com. That's OLOGIES.com.
They also, by the way, make one suitable for kids where they rip out all the swears. Those are called Zymologies. Big thanks again. This episode was produced by Pat Walters with mixing help from Ariane Wack.
And I don't think there are any special thanks, so I'm just going to thank you. Thank you for listening.
New episode in your feeds coming up in a couple weeks, and it is a really good one. It's an odyssey. Catch you then.
Radiolab was created by Jad Abumrad and is edited by Soren Wheeler. Lulu Miller and Latif Nasser are our co-hosts. Dylan Keefe is our director of sound design. Our staff includes Simon Adler, Jeremy Bloom, Becca Bressler, Rachel Cusick, Akedi Foster Keys, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Nyanasambandan, Matt Cutie, Annie McEwen, Alex Neeson, Sarah Kari, Ana Rasquet Paz, Sarah Sandbach, Ariane Wack, Pat Walters, and Molly Webster, with help from Andrew Vinales. Our fact checkers are Diane Kelly, Emily Krieger, and Natalie Middleton.